Hello Longhorns, this is the Pre-Calculus Test Review 4.1 for our first test for the spring semester. And I'm going to start with question number 1. A carousel with a 50-foot diameter makes 7 revolutions per minute. Find the linear speed in feet per minute of the platform rim of the carousel. Express your answer in terms of pi. Alright, so the first thing we need is the formula for linear speed. And these formulas will be provided for you on your test. So the formula we need for this is V equals R theta divided by T. So V equals R theta divided by T. And T is time. So R is the radius, theta is the angle, and T is time. So we're just going to take this information from our problem and we're going to plug it into the formula. Alright, so the diameter is 50, which means the radius is going to be 25 or half of that. Theta is going to be 2 pi because 1 revolution is 2 pi. 1 time around a circle is 2 pi. So our theta, or our angle measurement, is going to be 2 pi. And we do that 7 times. So I also have to multiply this times 7. All of that divided by time. So this is 7 revolutions per minute. So this is going to be per minute. So all I need to do now is put 25 times 2 times 7 in my calculator. And I get 350 pi radians per minute. And that is how you'll write your answer. 350 pi radians per minute. Okay, for problem 2, we're calculating the angular velocity in radians per minute of a spoke on a bike tire revolving 70 times per minute. So we're expressing our answer in terms of pi again. So now we need the formula for angular velocity. So the formula for angular velocity is omega equals theta divided by time. So omega is written as a W. So we just write it like this. It looks like a little W, and we call it omega. And it's omega equals theta divided by time. All right, so first of all, we need to figure out what our angle is. And so the angle is going to be 2 pi once again. And it's revolving at 2 pi. 2 pi is 1 revolution. It's taking 70 revolutions. So we have to multiply our 2 pi times 70 revolutions. And this is per minute. So our angular velocity is going to be, and we want to do this in terms of pi. So our angular velocity is just 2 times 70 pi radians per minute, and this is how we write it: 140 pi radians, RAD, per minute. And that's it. That's our angular velocity. All right, in question 3, we need to determine the sector area of a circle with a radius of 8 centimeters intercepted by a central angle of pi over 6. Round your answer to the nearest hundredth. Okay, for this one you need the equation or the formula A equals 1/2 R squared theta. Okay, so we just simply put our values into the formula. 1/2, 8 squared because the radius is 8. So we have 8 squared, and then our angle is pi over 6. So theta, of course, is our angle, so pi over 6. We put all this in the calculator, and the answer that we get is 16.67 centimeters squared. All right. All right, for question 4, we're going to convert 29 pi over 2 into degrees. So we're going to multiply by 180 degrees over pi. This is our conversion because 180 degrees equals pi. So if I'm converting to degrees, then I'm going to use 180 degrees divided by pi. What happens here is our pi's cancel out, and we simply multiply 29 times 180 and divide by 2. And when we do that, we get 2,610 degrees. Okay, let's look at problem number 5. In this problem, we're converting 780 degrees into radians. So we're going to do the opposite of what we just did. I'm going to multiply times pi over 180 degrees. Again, our degrees are going to cancel out. And we simply divide 780 by 180, and we leave pi in the numerator because we want our answer to be in terms of pi. So 780 divided by 180 equals 13 over 3. So the answer is going to be 13 pi over 3. And that is converting 780 to radians. All right, in problem number 6, we are converting 345.12 degrees into minutes, degrees, minutes, and seconds. All right, so we're going to take the 345 part. We're going to keep that as our degrees. And then we need to convert this 0.12 into minutes and seconds. So the first thing we're going to do is multiply the 0.12 times 60, because there's 60 minutes in 1 degree. So when I multiply 0.12 times 60, I get 7.2. Well, for this part, I'm going to keep the 7 for my minutes. I'm going to write it over here, 7, and the mark for minutes is just one hash mark or one apostrophe. Then I'm going to take my 0.2 that's left over from my minutes, and I'm going to multiply that times 60 again, because there's 60 seconds in a minute. So 0.2 times 60 gives me 0.1, or I'm sorry, gives me 12. So I have 12 seconds. So my answer is 345 degrees, 7 minutes, and 12 seconds. All right, in problem 7, I have a coordinate that's 408 degrees, 16 minutes, and 20 seconds, and want to convert that back into decimal degrees. So what we're going to do now is we're going to do the opposite of what we just did. We're going to keep the 408, but then we need to convert this 16 minutes into decimal form. So what we're going to do is we're going to add 16, and we're going to divide by 60 this time instead of multiply. Then we're going to add the 20 seconds. And what we're going to do here is we're going to take the 20 seconds and we're going to divide by 3,600. That's 60 times 60. Okay? And so when I put this in my calculator and I calculate it out, I get 408.106 degrees. All right, for question 8, we're going to use the unit circle to find the exact value for the following. The first one is sine of 5 pi over 6. So what you need to do is you need to look at your unit circle, find 5 pi over 6, which is going to be about right here, and you want the sine value. So remember that the sine value is the y value. So the y value for 5 pi over 6 is 1/2. So you want to find that on your unit circle. That's going to be your answer, 1/2. And you do that for each one of these angle measurements. The next one is cosine of 7 pi over 6. So the cosine of 7 pi over 6 is negative root 3 over 2. So basically you're just reading your unit circle. Tangent of pi over 6 is root 3 over 3. So you'll need to know where to look on your unit circle to find these values for sine, cosine, and tangent. All right, for question 9, it says, if the terminal side of angle theta goes through the point negative 5, 2, find sine, cosine, and tangent of theta. All right, so first of all, we're going to start by drawing a triangle, and we're going to use the Pythagorean theorem to help us find the third side, and then we're just going to put the ratios down for sine, cosine, and tangent. Okay, so here you can see that I've drawn a right triangle on a quadrant, and negative 5 is our x value and our y value is 2. And so we're going to use those values to find this hypotenuse, and we're going to use r equals the square root of x squared plus y squared. Okay, this is just the Pythagorean theorem. And then we're going to plug those values in to find the hypotenuse. So we get that the hypotenuse is the square root of 29. So when we start writing our values for sine, cosine, and tangent, we have to remember that we're going to end up with a radical and a denominator. So for sine, we're going to end up with 2 over root 29. Now I have to rationalize that denominator because we can't have a radical in the denominator. So we rationalize it by multiplying the fraction by root 29 over root 29. This gives us 2 root 29 over 29. And that will be our sine of theta. So 2 root 29 over 29. Then we do the same thing for cosine. Well, cosine is negative 5 over root 29. So again, we rationalize the denominator. Same thing we did for sine. And we get negative 5 root 29 over 29. So cosine is negative 5 root 29 over 29. Now for tangent is simply going to be sine over cosine, or y over x. So y is 2 and x is negative 5. So the way we're going to write that is just negative 2 over 5. That's going to be tangent. All right, for this problem, number 10, you're going to need a calculator for sure. We're going to find the third side of the triangle, and then we need to use our calculator to help us find the angle measure, because here we're trying to find the measure of theta. All right, so what we're going to need is, first of all, we need to find out what the sides are in relation to the angle that we have right now. Right now we have a side opposite the angle. Here's the angle. A side opposite the angle over the hypotenuse of the triangle. Remember, the hypotenuse is always across from the 90 degrees. So we have opposite over hypotenuse. Well, that's the sine. So we know sine of theta is opposite over hypotenuse. So we know that our sine of theta is 4/5. But what we want to know is what is theta. So for this, we're going to have to use what's called an inverse sine or an arc sine. So in our calculator, we have a button that is right underneath sine that looks like this. Sine, and it looks like to the -1, but that's inverse. So we have to invert this. So sine inverse, and then we're going to put in our 4/5 equals, and that's going to give us theta. That will give us theta. So we're going to put sine inverse of 4/5 into the calculator, and that's going to give us theta. Now, if our calculator is in radian mode, we're going to get the value 0.9273. Now that's in radians. So you could write that. You could say 0.9273 radians as your answer because, you know, theta could be in radians. If you wanted to convert your angle to degrees, you would simply multiply this 0.9273 times 180 over pi if we wanted to change it to degrees. But you don't have to. You can just write 0.9273 radians. It's not pi radians, it's just radians. But sometimes it's easier for us to understand where that's at on our circle if it's in degrees. So let's go ahead and convert that to degrees just by multiplying our radian measure times 180 degrees over pi. And when we put that in the calculator, we get 53.13 degrees. And that's it. So, I will accept this as an answer, or I will accept this as an answer. That's fine. But if you write 0.9273, you must write the word radians after it. I need to know that you know that that means radians. Okay, if you write it degrees, then you need to have the degree symbol, just like I have here. All right, for question 11, we're going to find the positive angle theta in radians that is coterminal with 17 pi over 6. Okay, so these problems, 17 pi over 6, and these problems you have to convert your 2 pi, which is 1 revolution all the way around the circle is 2 pi. I need to add or subtract 2 pi from the 17 pi over 6 in order to get my coterminal angle. And so what I need to do is I need to convert this 2 pi so that it has a denominator of 6. So I'm just going to multiply it times 6 over 6. And when I do that, I get 12 pi over 6. And so I'm going to add or subtract 12 pi over 6 from the 17 pi over 6 to get my new angle. So when I do that, I'm going to go ahead and subtract 12 pi over 6. I get 5 pi over 6. And that is on the, that is a coterminal angle that goes along with our 17 pi over 6. There's just 1 revolution difference between these two angles. Okay, so what this looks like is we start at the standard position and we go around all the way around to here. Now, if I did that, that's going to be my 17 pi over 6. So what we did by subtracting 12 pi over 6 was all we did was go back all the way around 1 time until we stopped right here. Okay, so we stopped at 5 pi over 6. So this 1 revolution all the way around that I just did, this 1 revolution right here all the way around, that's 2 pi. But I had to convert this 2 pi to 12 pi over 6 so that I was able to subtract it from this 17 pi over 6. And that's how we got our coterminal angle of 5 pi over 6. And that's the end of the review for the test. Good luck, and I hope you all get hundreds.